on the computer, share screen, and here we go. So this is a game, and it's a bit simpler than your project, but we have a grid, we have some characters, and the characters fight each other. And yes, we are recording. When one character moves into the square, blah, 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 there's some attack stuff, and there's some stuff to do with random chance. And we've got three types of entities. We've got a king, a queen, and a dragon. And then with each entity is associated a series of requirements. So the first part is use a suitable design pattern to model a solution to this problem. And we've already started the code. So we have some classes, and it's going to get messy. We've got lots of files, but let's just try and do what we can. And then, okay, so we've got this game class. That seems pretty fine. And then we read an input, and I think this is just reading where we're going to go. So like you say, move this character to this square. We can add character. Cool, that seems fine. And then the rest of we need to fill out. Oh, this night one's done for us. That's good. Okay. So what abstractions are we going to make here? We've seen the first one. Knight extends character. King. Okay, well, I guess king and queen are going to also extend character. We've all seen this before. And so character is an abstract class. That's cool. Now, why do I feel like this code has already been done? No, this has already been started. Okay. Never mind. So we have this attack method. Okay, this is abstract. That's interesting because we've got this method that uses attack, but we haven't actually defined what it is because it's abstract. Why does this work? How can we use an abstract method without actually having defined it? Yeah.
Because it has to be instantiated file. That's what it extends it. That extension has to define we're just calling whatever the extension class is attacking.
Yeah, exactly. Because you can't make a character, can you? Because it's abstract. So we have to make something that implements character, which means we have to define what attack is, which means when we call this method, make move, we will have implementation of attack. We'll see this properly in a second. Just makes it better. Cool. So that seems fine. And then we also have this can move, and that's the same thing where we have this method, but it's not defined. Okay, interesting. And let's look at the knight. So knight's been defined. This is our requirement here. We're just kind of understanding the code at this point. Oh, it's not even here. I guess it's already been done for us. Okay, let's do these other ones. And then we'll talk about the design pattern. So let's do dragon to start with. I'm going to bring these two up together so that we can not have to flick between them. I really wish I had a bigger screen when doing Tutes. That's what I like about teaching online. The very few things. So I'm going to say dragon extends character. Okay. As expected, we need to add the unimplemented methods in the abstract class. So a dragon can only move up, down, left, or right, and it has a 1 in 6 chance of inflicting 20 points of damage. Okay, so let's start with can move. So dx is our change in x, and dy is our change in y. What might we put here? Given dx and dy, what's our rule for moving? So let's have a look. Here's where our dragon is on this square. So we can only move like a king in, or no, king in chess can move like diagonally as well. You only move tiles cardinally adjacent to the one you're currently on. What does that tell us about the change in x and the change in y? Yeah. The absolute value of
each one.
Yep. Yeah, because we can only move one cell in one direction. We couldn't move diagonally, and that would be change in one, change in one. So let's do that. So return math.abs dx plus math. Oh, how do I do this? Cannot, what? I think this is fine. Okay, cool. That is fine. Easy. Okay, so now for attack. So we're given a victim, and that's also of type character. All right. It has a 1 in 6 chance of inflicting 20 points of damage. Okay. What we can do is, if we look at the knight, we see this like math.random greater than 0.5. So this means it has a 50% chance, right, greater than 0.5 of inflicting 10 points of damage. Okay, so what can we put here then, given this? Sorry. Not enough space. Anyone? So math.random returns just like a number between 0 and 1. It's like a probability scale, right? Where 0 is impossible and 1 is possible. So how can we say 1 in 6 chance? That's how we say 1 in 2 chance. Yeah. Yeah. Less than, it's like one of those, what should we call it? The thing in statistics where it's like a continuous distribution, like less than or less than equal to are the same, because the probability of something exactly is 0. It doesn't matter. 1/6. Does that work? Yeah, it does. Victim.damage 20. Awesome. Really needs more screen space. This still has a problem because we don't have constructor. That's fine. All right, 1 out of 3, 2 to go. Let's look at king next. So they can move 1 square in any direction, and they can always cause 8 points of damage. All right, first one here, nice and easy. Yep. And we'll take out this magic number and pull it into a constant. Private final damage equals 8. Attack damage. We should have done that on the other one as well. That's okay. All right, so can move 1 square in any direction. All right, so before we just did cardinally, what about diagonals as well? There you go. Any thoughts? Yeah. What if you tried to move here? That would be less than or equal to 2. Yeah, that sounds good. So return math.abs dx and 1. Cool. Now we need to do a constructor. Yeah. Like adding them together and doing like a hypotenuse thing. Yeah, I guess you could. I don't know. It doesn't really matter, to be honest, but too many square roots in that for my liking. Okay, queen. Extends character. Cool. And the rules of this are any square in the same column, row, or diagonal as she is currently on has a 1 in 3 chance of inflicting 12 points of damage, or a 2 out of 3 chance of inflicting 6 points of damage. All right, let's do the attack one first. Any thoughts, any ideas? So it'll be something if math dot random. 1 in 3 chance of inflicting 12 points of damage, or a 2 out of 3 chance of inflicting 6 points of damage. So before we said, okay, 1 in 6 is less than 1 over 6. Yeah, David? Yeah, so this should work. Where, like, if we get to the else clause, then it must have been the later 2 out of 3 because it wasn't the initial 1 out of 3. So, what is it? 1 out of 3 chance of, I'm not going to bother putting it in a variable. I can't be bothered. 12 victim dot damage 6. Cool. And then for movement, what can we do? Can anything in the same column, row, or diagonal. So now our bounds have gone like this. So you go, you probably all know how queen moves in chess. But it just has to be the same. Yep. Yeah. So if dx equals get x, so this means we know we're in the same column and, sorry, same row. Or actually, sorry, what I'll say is return this. Return dx equals get x. And or dy equals get y. Or what's the other one? Yeah, that makes sense because they're on the same, they've traveled the same distance, so it's a diagonal. Do you have anything else?
I wouldn't be absolutely right. One's positive, one's negative. So it shouldn't be get it should be 0 because it's
Oh yeah, yeah, that's true. That's the distance. The negative one though, it's like you could have, you could go, yeah. We have to do this? Yep, cool. All right, and last but not least, a constructor. So we wrote all this code, which was fun, but the design was kind of already done for us. What does anyone know what pattern we're using here? Oh, I might just run it as well, just to show you how it works. Oh, nothing happened. Okay, oh, sorry, I need to add the characters. Yeah, okay, move the king to, let's say we try to move to 2, 0. It's just that, invalid move. Move the dragon to 0, -1. Oh, that's also invalid. Oh, because I can't do it. Move the queen at 2, 2 to 4, 2. So that worked. And now nothing happens, but you kind of get the idea. And then there'll be like an attack if an attack happens. The overall point, if we go to the game, sorry, not the game class, move result. Where are we? Character, oh, it's in the character class. Okay. Yeah, the point being is if you hit on the same tile as another character, then an attack will happen. But what's the pattern? if we think about this make move function, you can think of it as like a sort of high level recipe where it says, well, whenever any character makes a move, we're going to run these series of steps. So we're going to check this, and then we're going to, go through all the characters and check if the, the coordinates are the same. And then if so, we're going to attack, and then here's some more steps. So you kind of get this recipe-like process. Here's our process. And then there's step one, which is, up here. And then step two is not actually defined, right? Because can move, we haven't actually implemented in the superclass. So can move is abstract, and it's done by whoever implements the abstract class. And then let's say step three, we do that ourselves. And you might think of some of these as actual separate methods that live in a superclass. And then step four is also delegated. And then step five is done by us as well. Okay. And so what you get is there's some stuff where it's all some stuff is pre-filled out, and some stuff that needs to be filled out by the subclass. Any words that come to mind? Yeah, it's a template. You like if you go into, I'm gonna just freeze before I switch windows, but like if you go into, right, here we go. If I go new from template, you'll see that, like I can get a template and some stuff will be filled out for me, and then I can fill out the rest. That's the idea of a template. So the template pattern is when you're given a process and some steps are filled out for you in the superclass, and then some of them and when I say you, I mean the particular concrete implementations have to do themselves. So in this case, step two and step four are, which in this case is can move and attack. They're abstract. They're kind of, what's the word? They're abstractly declared, like these methods exist, but we don't know exactly what they are. And what we call these, does anyone know what these are called? I don't know if you can see this. It's a bad drawing. I've just drawn like the Nike logo. Anyone know? These abstract methods are what we call a hook. So that someone that comes and uses the template, which in this case is our dragon, king, or queen, can go and hook onto the methods and say, okay, well, here's this declaration. Now I'm going to go actually define it. And that's what we do here when we define attack and can move. That's kind of the template pattern in a nutshell. I don't really have too much else to say about it. Other than it's a static pattern. So a lot of people kind of get the strategy pattern and the template pattern mixed up. And usually it plays out like a situation where we've got a question and the answer is a template pattern, and they say, oh, it's a strategy pattern. The reason most of the time it's not a strategy, but like in this case, you could say, oh, well, you could have a queen strategy, a king strategy, and a dragon strategy, and each of them have different, attack and can move implementations. And in our character class, the character, is composed of a strategy that will, have one of these two. And so when you call this, you can just say, strategy.attack, strategy.can move. Why is it not a strategy pattern though? Why is that logic flawed? Anyone? Why are these not strategies? Think about the idea of strategy that we talked about back in week 5. What's the kind of defining characteristic of it? We had the happy hour strategy and the discount strategy and the members strategy. What did you notice about it? I think, and we asked the question at the start, when you have a strategy, for like me doing the course or doing term 2, and you're like, this is my plan, my strategy, and then you can, what can you do? Yeah, you can change it. Can you change this? No, I mean, nowhere in the requirements does it say, oh, a king can suddenly turn into a queen at this point, and a queen to, like in chess, that's kind of a strategy pattern, right? When the pawn gets to the end of the board and they suddenly turn into a queen. But here, it's like, well, if I'm a queen, I'm staying a queen. So, what else? Yeah, so that's why it's static in that sense. And it's more about the process with a series of steps rather than strategies that can chop and change. Cool, let's do the decorator pattern now. Evolution of requirements, everyone's favorite. So now we go, okay, cool, that's great. But we want to give buffs to the characters in the game. Now, I really like this exercise. Well, I kind of like it because it's nice and cute, but some people look at this and they're like, oh, we should have done that in our project. Don't do this in your project. It's not a waste of time, but it's an over abstraction because the changes we're about to make are so tiny. I'll tell you how to do it at the end, but this is just to illustrate the decorator pattern. So let's do it, and then we'll talk about the concept because I think that's fun. So we have to have different sorts of armor. Actually, I might need to talk about it before I do it. Let's start with this character abstract class. What we're going to do is we're going to change it to a base character or character base. And this is going to mess with everything, but we'll figure it out. So character base .java, and then we're going to make a new character.java, and we're going to move some stuff from the character into the character base. So we'll move not the constructor, we'll move getX and getY and damage, and in fact we'll move most of these. Make move, toString attack can move, but we're going to make this an interface. And I'll explain why in a second. Get rid of this. So we don't need to actually make this abstract because everything is abstract in an interface. There's going to be a bug with this implementation. This is another reason I'm not the biggest fan of this exercise, but it'll be fine. So we've got our getters and our health points, and now we have our nice interface. You think that's cool. And what we're going to do is we're going to say character base implements character. And you can have this. You can have an abstract class implement an interface. Oh, sorry. Oh, that's all good. These are all complaining. Let's just change this to character base. Great. And now game's complaining because add character. Add character is not applicable for the types dragon. There we go. Great. All our red lines went away. Why is that useful at all? We just made another abstraction called character. So now we have this big hierarchy going on. Well, it's because what we're going to do is we're going to have two types of character. Here's our overarching character interface. And then the first one is our character base, which has our template pattern with 3 implementations, dragon, king, and queen. That all goes up like that. And this is that. And now what we're going to have is we're going to have another sort of subsection of the hierarchy, which is a decorator. And the decorator also implements the interface. Okay. And we're going to have, I think it says 3 types. Let's just do 2. We'll just do the chainmail and the chest plate. We've got chainmail and chest. So here's our rough UML diagram. Cool. And we'll make a folder here called Decorator. The first one will be character decorator.java. This is going to be abstract because this isn't a real decorator. This is just the overarching idea of a decorator. And both of our subclasses are going to use this and implement some specific behaviors. So, okay, well, what does the decorator actually do? Well, in this case, we want to, what do we do? Reduce the amount of damage by half, and a chest plate caps the amount of damage at 7, blah, blah, blah. We'll do this in a second. So conceptually, it's like, here's my character. And they can be dragon, king, queen. And if I do say, well, I'm going to give them, you know, a helmet. This is a helmet, looks like a top hat. And what that's going to do is it's going to wrap around the character. And so any functionality we run on it it'll happen at the actual individual character level. But then what we want to be able to do is take that and say, okay, well, you know, here's the attack damage that was done on it. Now I want to change that by some value. So that's what we want to do here. We want to say, reduce the amount of damage by a half. Okay. How do we realize this? We've got this sort of wrapping of stuff, and you've all seen wrapping objects before, right? You know, this idea where you have something and then you have a wrapper around the object. And the wrapper is just a very thin layer of, you know, maybe one extra bit of functionality. And the decorator pattern is just sort of wrappers on steroids. Like last week, we did the wrapper with a generic stack, right? It was just a wrapper around the array list. So what we're going to have in the class is a private character, and I'll explain why it's a character in a second. If you can figure it out, then let me know. So private character inner. So this is the thing we're wrapping around. And then we're going to say public character decorator. And just initialize that. And what we also need to do is say character decorator implements character. We need to probably import it. What? Import thrown stuff character. Cool. Now notice it's not actually giving me any red warnings because this is an abstract class. This isn't a concrete implementation. But if I now go, what is this? Chainmail decorator. And this is going to extend character decorator. Now I have to not only implement the stuff that was in the abstract class, I also have to do the interface. So we're going to actually take some of these and put them in the abstract class so that we don't have to deal with them because they're common among all the decorators. All right. And most of this stuff is just going to be palmed off to the inner, like the health points. We're going to say return inner dot get health points. Get X, palm it off, return inner dot get X. Same thing with Y, return inner dot get Y. Now I think, okay, so damage is like this takes damage. We're going to want to change this, right? Because we're going to want to take the damage and reduce it by half. But we run into the problem we saw a few weeks ago where this is private. And if you're thinking ahead, you can't actually access this in the subclass. So what are we going to need to do? I don't know if it's Tute. I think it was Tute 3. We were talking about like we weren't actually writing code, but we had this idea. We were talking about the thing of like, you want to access the speed in the superclass, but then you want to access it from the subclass, but you don't want to make it protected or anything ugly like that. There's a nice clean way to do it. So if anyone remembers, put your hand up and we'll do that. In the meantime, move result, make move. So we'll just say return inner dot make move. Just pass everything along. And then attack will be the same. Oh, sorry. And same thing for the can move. It's like we're going to want to do stuff with this in the next bit of requirements, but we can't actually access the inner in the subclass. So for now, we'll just say return inner dot can move. And you think this is kind of useless, right? This is just a wrapper that does nothing. But what we will do is change this so that it becomes quite useful once we start using our inheritance. So chainmail decorator. Now, most of this crap we can get rid of now because we've already dealt with that. We've already dealt with this. We've already dealt with this. We just need to change damage and add a constructor. So what can we do here? We can't actually access, we want to say, well, here's our chainmail of the character's wearing a decoration, but we can't access the inner because it's hidden in a superclass. What can we do? Yeah. Yeah, we don't really want to create a new object. We want to modify an existing one, right? What can we do? Remember, we've got our super decorator class and we've defined the method damage inside it somewhere. Where do we do it? Here it is. So maybe we can use this somehow. Because what we really want to say is inner.damage points divided by 2. But we can't do that. We can't access it. So how could we make use of the superclass? So that's this. Yeah. So we say super.damage points over 2. And again, this is just a wrapper around the wrapper, right? Where you say, okay, well, we can't access the inner object, but we can palm it off to the superclass, which does have access. Cool, that's the chainmail one done, nice and easy. And then next one is the chest plate decorator. .java. And then this will also extend, what is it? Character decorator. Add the constructor. And then this one caps the amount of damage to 7. Okay. What will this look like? Oh, sorry. There we go. If the damage is capped at 7, we just take the minimum or maximum? Minimum, yep. Math.min points, we'll say private final int max damage equals 7. Cool, that's done. And then we need to also app override public boolean can move dx and dy. So now, chest plate, blah, blah, blah. If the character is otherwise capable of moving more than 1 square at a time, then this armor restricts each moves to distances of 3 squares or less by Manhattan distance. Okay, let's break that down. So we've got a few kind of possible conditions, right? First one is the character capable of moving, what is it already? As in without the armor, or without the, what is it? Yeah, without the armor, can they move already? If yes, then we need to check some more things. If no, then well, they obviously can't move, so we return false. Okay. And then if they can move, we do this 3 squares check. So 3 squares check. If they can, yes, otherwise no. All right. What's the first step then? We need to check if they already can move chest plate decorator aside. What do we need to check? Yeah. So super.can move dx, dy, or if I should say, if not super.can move, then we just immediately return false. Otherwise, we need to do this Manhattan distancing. What can we do here? Yeah. Oh, sorry. Yep. Yep. Oh, sure. Okay, it's like this. Plus, why do you need the existing coordinates? I think you can just get rid of these and then check that. All good? Yeah, that's pretty fun. Cool. And this is all really simple. And the reason I say this is like a simple example is because you would not have a real class like this. There's too few lines of code. It's not really doing anything. So it's a lovely analogy. It's another lovely, like, oh, you know, you can decorate with armor and stuff. It's like in your projects, you just have a list of all the items in the inventory, and then your total buff is you go through and sum up the items, right? Yep, roughly. Cool. There's one really powerful thing that I haven't touched on yet, and that's why we store a character here. What does this allow us to do? Yeah, rhythm. Yeah, you can add as many decorators as you like. So if we go to, I don't know, character, no, we go game. So we can say new queen, but then we can also say, well, let's wrap the queen in a chest plate. And what we do is we give it a character to the constructor, right? We need to import this. And a queen is a character. But then we can also say, oh, well, let's even wrap it again. Let's wrap it in a chainmail. We import that as well. And because a chainmail takes in a character and a chest plate decorator is a character, you can put that inside as well. So we can have as many decorators as we want, and we just keep wrapping and wrapping and wrapping and wrapping. And in color. Hello. Is this person know you? You can come in. Oh, all good. Sorry, I didn't recognize. Like, who is this guy? What is he doing here? Why is he knocking on the door by Tute? Here's our base character. And then we can wrap it, and we can wrap it again. We can wrap it again, and we can do it as many times as we like. And then we say, okay, give me the damage. It will go and look at the first layer. And that will say, well, mate, where are we? Decorator, yep. I'm just going to palm it off to the next one and the next one. And then maybe at each layer you provide some sort of small wrapping functionality where you max out the damage or that sort of thing. But the key idea is you can have as many layers as you like. Very powerful. Do I have anything else to say about decorators? I mean, you've seen like decorators in Python, right? And yeah, we've got 5 minutes. What's a good example? I might just search it up. Python decorators of decorators. It gets a bit weird, like, and in Python in particular, because there's all this like functional stuff you have to deal with, but you can have this thing where it's like you can, this is hello wrapped in this upper function, which is also wrapped in this wrap function. The syntax is a bit weird, and you start to deal with like functions as first class citizens, which we're all pretty familiar with by now, but it's still a bit weird where you have functions returning functions, and which is like currying. If you've done Haskell or any Haskell course, then this is probably sort of second nature. But yeah, decorators, or I guess what I'm trying to say is you can apply them at a functional level as well. I think that's what I'd say. Let's spend the next 5 minutes. Oh, are there any questions about this? No? Cool. All happy. Let's do some revision questions. I do actually really like the builder pattern, but it's not core content, so I won't worry you with it. Let's do some revision questions. Theory. Let's pick some good ones. Some of these questions are very Java specific, and this is when the course is more about like OO programming and sort of Java than it was about like software design. So this stuff where it's, yeah, this stuff here where it's like, I don't know what the answer is, but it's more just like being able to look at code, which is not super helpful. This one's kind of more interesting. But again, it's like, if you understand how abstract classes work, then it's pretty straightforward, and hopefully you'll know that by now. So we want to kind of give you some more interesting stuff. Yeah, like, see, this one is just like a Java question. We wouldn't ask you that. Yeah. Because most of these you can just Google, which is not very interesting. Here's one's better. Principle, choose the incorrect statement. Principle of least knowledge reduces dependencies between objects and promotes loose coupling. The code below is a good example of the law of Demeter. According to the principle, accessing methods on objects returned by a method call is invalid. You can read. The principle of least knowledge states that blah, blah, blah. Any thoughts? Who reckons it's A? Put your hand up. Who reckon, so the incorrect statement, yeah, who reckons it's B? Who reckons it's C? Okay, all close your eyes and just take a guess. You have to take a guess, but you have to close your eyes so that you won't be like, oh, I don't want to put my hand up because, other people, blah, blah, blah. All right, you got to close your eyes. I'll give you 5 seconds to discuss it if you want as well. 1, 2, 3, 4. All right, or close your eyes. We're going to play heads down, thumbs up. Okay, put your hand up if you think it's A. Put your hand up if you think it's B. Put your hand up if you think it's C. Put your hand up if you think it's D. All right, open your eyes. So the people who said B were correct because that statement is incorrect. Why is that incorrect? Isn't the law of Demeter thing like car dot, actually, that's dangerous. I'll go back to here. Right, car dot get driver dot get address. Right? So this fixes it. You've moved it. You've got it two separate variables. What's wrong with it? We haven't got the chain call anymore. The problem here is that you're still reaching across. You've just put it into 2 separate variables instead of 1. Like, it doesn't actually do anything, right? You get the driver, and then from the driver you get the address. But now you've got the class, which whatever this class here is, reaching over into the address class, and that's bad design. Now, a lot of you thought it was C. According to the principle of least knowledge, accessing methods on objects returned by a method call is invalid. We have seen this in action with streams, right? I don't have the code here, but when you say, list.stream dot map. These are all returning another stream object, and we're just calling more methods on it, which allows us to do this chain call. But we're not actually reaching inside other classes because the chain call with getters, which isn't there anymore. The chain call with getters is saying, give me this, give me this, give me this, and you're reaching over and breaking the law of Demeter. Whereas here we're just saying, we're just sort of adding on to the existing class, if that makes sense. All right, let's do one more question. Oh, this one's cool. One other thing I didn't talk about, the decorator pattern. Actually, I've spoiled it. I should have kept my mouth shut. But the answer to this one's the decorator pattern, because not only can we, wrap functionality, we can do this at runtime. So we can say, where are we? In the game class, we can actually say, okay, well, now the queen has picked up a chest plate, wrap them in a chest plate, and it'll all still implement the same interface, and it'll still work with everything else which it expects a character. If it expects a queen in particular, then you kind of run into problems, because then you're like, well, like if you have a bit of code that's like, blah instance of queen. The problem is the thing you're passing in isn't a queen anymore. It's a decorated, it's a chainmail wrapping over a queen. So you be careful of bugs like that. I think there's a bug in here to do with this. Actually, I don't know where it is. It's in this make move method, I think. But anyway, yeah. So you can do this at runtime. Is the key takeaway. Let's do one more where you have to guess. Yeah, let's do this one. Which of the following is not a code smell? You got 10 seconds to talk about it and figure it out. Question 17. All right, close your eyes. Heads down, thumbs up. No. Put your hand up if you think, you don't actually have to put your heads down. That was a joke. But you have to close your eyes. Put your hand up if you think it's A. Put your hand up if you think it's B. Put your hand up if you think it's C. Yeah, this question was too easy. It's A. This one's good. This one's good. Question 18. This is an interesting code smell. All right, close your eyes. We're not starting until everyone's got their eyes shut. All right, who thinks it's A? Who thinks it's B? Who thinks it's C? Who thinks it's D? Okay, open your eyes. Most of you thought it was D. Honestly, I mean, I think that the prescribed answer is D, but like you could say A as well because, ooh, that's so weird. Because a data class is just a struct. And, we talked about like back in the Tute 4 when we did the, the booking system, that there are all these data classes that it's just like a bunch of fields and a bunch of getters and setters. And so it functions as just a struct. But the problem is, it's like that functionality that was supposed to be in that class is being stolen by another class. And then that class was really complicated and tightly coupled and that sort of thing. So like it's fine to have a struct, right? You could have and I think some people, like people in the forum are like, oh, could we have a health class? And it's like, well, that's really just gonna be a struct, but that's fine. Like there's this concept of health that, makes cohesive sense. But the indication of a data class, or similarly a lazy class, where it's like this class that doesn't do very much, is either that class doesn't really deserve to exist, and could just be a variable or something in another class, or someone is stealing functionality and you need to give it back. Oh, this one's cool. Sorry, I know we're going over time, but I really enjoying this. Let's do one more because the rest of the questions are kind of yeah. This one. Okay. When code has sets of variables usually passed together. This is a good one. Which code smell? All right, close your eyes. Who reckons it's A? Who reckons it's B? Who reckons it's C? Who reckons it's D? Okay, open your eyes. The answer is C. And you know, like when you're doing the dishes or something and you get these disgusting clumps of goo that are like, they've accumulated on the dishes and you have to, scrape off the clump and then it all goes into the sink and everything's disgusting. That's why I hate washing up. And so data clumps is when you get these kind of variables that are kind of stuck together and they sort of move around together and, they're going through the code base. And that's a code smell, just like, when you're doing the dishes, because you think that's why are these being stuck together? And again, actually, I'm going to ask you this. What's the difference between a code smell and a problem in the design? Does anyone know? This is really important to understand. Yeah, David.
Code smells might be an indication that it's bad design, but it might not necessarily mean it's bad design.
Yeah.
Then bad design is bad design.
Yeah, like bad designs. Remember when we did I think the coupling and cohesion tube, we talked about this idea of, what is good design? And it's like this really intangible thing, and it's really hard to tell. And it's also hard to tell what bad design is well. And you can get these, like you can get code that looks perfect, it's great, it maybe makes use of design patterns and stuff, but it's still not that well designed. I might talk about this next week when we do visitor pattern, but it's very easy to engineer solutions that are they're not actually like solving the right problem. It's like you solve this data clumps thing by, like, this is a great example, right? When we go back to this one here, where you're like, oh, well, I've got this chain call, which is a violation of the law of Demeter. So let's split it into variables. It's like, you haven't done anything here. All you've done is split it into two different variables. You haven't actually solved the problem. You've just sort of moved it into two lines instead of one. And yeah, so like the data clumps is an example where it's like, maybe this was the best solution for the design you had because the design you had was crap in some way. So refactoring and going and this is like sort of root cause analysis on a design level where you're like, okay, what's the actual problem here? It's like, well, this class and this class really should have some sort of connection, but they don't. And so you're having to do all this pass the parcel crap, to get information from over here to over here. Yeah, so I guess that's the key difference. Sometimes it's like the smell is right next to the design problem, but sometimes it's a bit further and a bit harder to tell. And yeah, you can have like today, for example, I've just started a new job and I'm working in this team that's working on this massive repo, like this massive monolith monorepo, it's the Jira, like for Atlassian. And it's huge and there's so much code. And we were talking about using design patterns to make it more extensible. And the problem is when you get to a certain point, you're like, oh, we've got this problem. We use a design pattern to solve it. But then it's like, you haven't really solved the actual problem. You've just kind of, sort of done this kind of patch fix or this, like put a Band-Aid on it. And it's really hard. It's really hard to get it right, especially once you get, bigger and bigger code bases. And you're probably, seeing this firsthand with your project, where you're like, oh, we need to go change this. Oh, let's put this little thing in, this little kind of stuff on top, and that'll fix it. And you keep doing that again and again and again. You get Jira, I guess. Anyway, I haven't been there very long, so yeah, it's very, very interesting to study. But anyway, are there any questions on anything we talked about today? Cool. I will stop sharing and